Hi guys, so we're ready to look at section 6.2, which is how the sum and difference formulas. So the first objective that we want to be able to do is we'll be introduced to what the sum and difference formulas are for sine and cosine, and we want to be able to apply them, right? So you can see here, the very first thing I have is I left some room for us to derive the difference formula for cosine. But I'm actually going to leave this up to you to review if you're interested. So I'm just going to write, C completed notes and or textbook if you're interested to see how that formula is derived and how we can think about that, and then try to derive the others as well, right? I don't want to spend too much time on that since this is not a proof-based math class, right? It's just it's trigonometry, so introductory level type class, right? So what I want to do though is just list some motivation, maybe for why we might, someone might be interested to look at these sum and difference formulas, right? So, if you're, just thinking about some things we've learned about, right? Like, for example, we know that sine of 60 degrees is equal to radical 3 over 2. And we know that sine of 30 degrees is equal to 1/2, right? Then, you might be curious, is sine of 60 degrees equal to sine of 30 degrees plus sine of 30 degrees, right? That seems like maybe a interesting claim, right? This is a question mark above the equal sign, right? We're testing, is this true? We don't know. So, sine of 60 degrees we know is radical 3 over 2, and sine of 30 is 1/2. So if we just substitute those values in, we get this, statement, and this is not true, right? Because this is equal to 1, and 1 is not equal to radical 3 over 2. So, I don't know, it kind of makes you curious, right? If we can somehow express maybe, sine of u plus or minus v and cosine of u plus or minus v in terms of trig functions of u and v alone, right? Would that be possible? And it turns out we can, right? So, if you go here to page 3 in the notes, you'll see the sine and difference formulas in a nice table here. And these are the 6 formulas that we'll be using, in this section, right? So you'll see, like, for example, example 1. So far, we're kind of limited in the angle measures that we can find the exact trig values for, right? So basically right now what we're limited to is what's on the unit circle. But with these formulas, it gives us a lot more possibilities, right? So for example, example 1, we can find the sine of 195 degrees, right? Because this is equal to, sine of 150 degrees plus 45 degrees, right? Because 195 is equal to 150 plus 45. And 150 and 45 degrees are, we can get from the unit circle, right? So then what we would want to do is use the appropriate formula. So this would be a sum of sine formula, right? This formula. So we can just fill in those values. So this is my u, and this is my v, right? So then this would be equal to sine of 150 degrees, so just using the formula, sine of 150 times cosine of 45 degrees plus, let me write this a little better, plus cosine of 150 times sine of 45 degrees, right? So then I can just fill in the values I know, right? So sine of 150 is 1/2. Cosine of 45 degrees is radical 2 over 2. plus, and then cosine of 150 is negative radical 3 over 2 times, and then sine of 45 is radical 2 over 2. Right, so we can fill those values in. So then what we end up getting is radical 2 over 4 minus radical 6 over 4. And then I can combine these two fractions, right? Subtract these two fractions, we get radical 2 minus radical 6 all over 4. Right? And I'll just leave it like that. So that's the exact value. Right? So then, cosine of 5 pi over 3, right? And just a note here, right? If you're having trouble doing the, 45, 150 degrees, right? We could, easily draw these, right? So like here would be, let's say 150 degrees. So this is 30 degrees, right? So that's 60. So this would be, radical 3, 1, 2, and this is negative, right? This x, because x coordinate's negative. Right? And then, and if you wanted, you could divide everything by 2 and make this be 1, right? Make it a little easier on yourself. And then, of course, you could come in here for the 45 degrees. So this would be radical 2 over 2, radical 2 over 2, and 1. Right? And then you can just find those values, right? Directly from that. Same thing with part B, right? So with part B, we want to think about how could I come up with 5 pi over 12, but using the angle measures from the unit circle, right, that we already know. So it turns out that what we'd want to use is that 5 pi over 12 is equal to 2 pi over 3 minus pi over 4, right? So coming up with this relationship, with known degree values might take some thought, a little bit of thought, but you could figure it out, right? So then this would be, cosine of, so this would be 2 pi over 3 minus pi over 4. Right, so this is like my u, this is like my v. So what we're using is the difference formula for cosine, right? So we're just applying that formula, just plugging in the u and v, right? So this would be equal to cosine of u, 2 pi over 3, times cosine of v, which is pi over 4, and then plus sine of u, 2 pi over 3, times sine of v, which is pi over 4. Right? So then, as I said before, you can come over here if you need to, and 2 pi over 3 look like this. So this angle would be pi over 3. So this would be, pi over 6. So pi over 3, this would be radical 3 over 2. This would be, let's see, negative 1/2. This is 1, right? So you can get those values. And then the other angle we have is pi over 4. Right, this would be radical 2 over 2, radical 2 over 2, and 1. Right, so you can use those to find those appropriate sine and cosine values. So cosine of 2 pi over 3, let's see, that would be, so that would be negative 1/2, right? So we'd have negative 1/2 times radical 2 over 2 plus, and then sine of 2 pi over 3 would be radical 3 over 2, and then sine of pi over 4 would be radical 2 over 2. So then, multiplying those fractions, we get negative radical 2 over 4 plus, so this would be, radical 3 times radical 2, which is radical 6 all over 4. So then this is equal to radical 6 minus radical 2 all over 4. Right? So I flipped the radical 2 and radical 6 just to make it look a little cleaner. Alright, so then this next one, example 2, we want to be able to find the exact value of the expression cosine of 99 degrees times cosine of 36 degrees minus sine of 99 degrees times sine of 36 degrees, right? So basically we're kind of going it backwards, right? So what I would be looking for is like cosine, 2 cosines, and then subtraction, and then 2 sines, right? So essentially this formula matches up with what that other thing looks like, right? So this is like my u, and this is like my v, right? So this is going to be equal to cosine of u plus v, right? I'll just write that above just to remind us. So that would be 99 degrees plus 33 degrees, right? Well, this would be equal to, so 99 degrees plus 33 degrees is 135. This would be equivalent to cosine of 135 degrees, which 135 is a value on our unit circle, right? So, here's 135 degrees, so there would be 45 degrees here. So this would be radical 2 over 2, would be negative, radical 2 over 2, and 1, right? So cosine of 135 degrees is equal to negative radical 2 over 2, right? Be equal to this value. So we're kind of, using the formula to work backwards to be able to find the exact value. Right? So then now, looking at example 3, so we're going to be able to find the exact value of cosine of alpha plus beta, given that sine of alpha is 5/13 and cosine beta is 5/6 for alpha in quadrant 2 and alpha or beta in quadrant 4. Right? So, let me just write a few things down here. So what we know is that cosine, oops, that's a little thick. Cosine of alpha plus beta, using the formula, is equal to cosine alpha times cosine beta minus sine alpha times sine beta. Right? So I know sine alpha is equal to 5/13, and I know that cosine beta is equal to 5/6. So I need to find cosine of alpha and sine of beta. Right? So I'm going to draw a picture here to help me. So we know that alpha is in quadrant 2. Right, so there's that. And we know that sine of alpha is equal to 5/13, which would be equal to, the y value over the radius, right? So what I know is that this is 5 and that this is 13. Right, so then I can use Pythagorean Theorem to figure out what x is, right? So we'd have, 5 squared plus x squared equals 13 squared. So this would give me 25 plus x squared equals, so 13 squared is what, 169? So then if I subtract 25 from both sides, that leaves me with x squared equals 144. So then that leaves me that x equals, plus or minus 4, right, in general. But in this case, since we're in the second quadrant, my x is going to be a negative value, right? So this is equal to negative 12, right? So what we're trying to find here is cosine alpha. So cosine of alpha would be equal to the x value, negative 12, over the radius, 13. Right? So then I do something similar to find sine of beta. Right, so let me use a different color and think through that. So we're told that beta is in quadrant 4, right? So somewhere down here. So this is angle beta. What else we know is that cosine of beta is equal to 5/6, right? Which that's equal to x over r. So in other words, I can set the radius be equal to 6, the x value is 5, and there's my y, right? The y value we're trying to find. So if I use Pythagorean Theorem, we would get 5 squared plus y squared equals 6 squared, which will give me 25 plus y squared equals 36. I can subtract 25 from both sides, and I'm left with y squared equals 11, which implies that y equals plus or minus radical 11, right? So in this case, in the fourth quadrant, my y value is negative, so this would be equal to negative radical 11, right? So that tells me that sine of beta, right, that would be equal to the y value, which is negative radical 11, over the hypotenuse, the radius, which would be 6. Right, so if we fill these values in, right, we get cosine of alpha plus beta. Right, I'll just say cosine of alpha plus beta is equal to negative 12/13 times 5/6 minus 5/13 times negative radical 11 over 6. Right? So this is equal to, so if we just multiply straight across, we would get negative 60 over 78 plus 5 radical 11 over 78. Right, so this minus and this minus, that will make a plus. Right, which we can combine this to be one fraction to be 5 radical 11 minus 60 all over 78. Right. Right, so that one took some work, but we could think through it. All right, so so what we have now is we want to find the exact value of cosine of inverse sine of negative 12/37 plus inverse tangent of 5/12, right? So with this, what I would be thinking about is this is equal to cosine of u plus v, right? And this equals cosine of u plus v is equal to cosine of u times cosine of v minus sine u times sine v. Right, so just keeping that in mind. So what I would do, down here is, let's say, let let u equal inverse sine of negative 12 over 37, right? Where u is in between negative pi over 2 and pi over 2, right? So this would give me that sine of u is equal to negative 12 over 37. Right? So notice, I need to find sine of u, but I also need cosine of u, right? So kind of like before, what I need to do is draw a diagram. So if sine of u is negative 12 over 37, remember, inverse sine, we're going to be stuck in between negative pi over 2 and pi over 2, right? So we're in the first and fourth quadrant. Sine u is negative, so that means I'm going to be down here somewhere, right? So then, the y value is going to be negative 12, and the radius could be 37, right? Because this is equal to, y over r. So I need to figure out this x value, right? Because cosine of, so this this part here is u. So cosine of u is going to be equal to x over r, which is x over 37, right? So all I need to do is find this x value, right? So I can find that using Pythagorean Theorem. So we would have x squared plus negative 12 squared equals 37 squared. So right, so if we subtract, this would be 144. So this would be x squared plus 144 equals 37 squared. So if I subtract 144 from both sides, we get x squared equals, so if we do 37 squared minus 144 in your calculator, you should get 1,225, right? So if I take the square root of both sides, you get x equals plus minus, so this is 35, I believe, right? So you can just double check. If you open up your calculator, so we want to do 37 squared minus 12 squared. Yep. So take the square root of that answer, and we get 35, right? So so it's here, since we're in the fourth quadrant, x is understood to be positive. So this x value is equal to positive 35, right? So this would equal 35 over 37, right? So the important thing to note is that cosine u is 35 over 37, and we know sine of u, which I need to change color to show up on the black, right? So sine u we found to be negative 12 over 37. Right, so we found those values. Now what we need to find are the ones associated with v. Right? So I'm just going to come over here to the side. So let's let v equal inverse tan of 5/12, right? Where v is going to be in between negative pi over 2 and pi over 2, right? And not including those values. Right, so in other words, here's my unit circle. We're going to be stuck in between here, right, for u and v. So tangent, so this would imply that tangent of v is equal to 5/12. So since we're positive, v is going to be somewhere in the first quadrant, right? So this here is angle v. Now remember that tangent of v would be equal to y over x, right? So the y coordinate is 5 and the x coordinate is 12. So we don't know r, which would be, I'll just label here r. So then using Pythagorean theorem, we want to, solve for r, we get 5 squared plus 12 squared equals r squared. So this is 25 plus 144 equals r squared. 25 plus 144 is what, 169 equals r squared. So if I take the square root of both sides, this leaves me with r equals plus minus 13, right? And r is understood to be positive in this case, right? So r is just 13. So in what we want sine of v and cosine of v. So sine of v is equal to y over r, and cosine of v is x over r. So just filling these in, this would be 5/13 for sine, and cosine would be 12 over 13. Right, so just picking those values, right? This is y, this is x, and that's r. It's 13. Right, so now I have those missing values that I was looking for. Right, so sine of v is 5/13, and cosine of v is 12/13. Right? So just following along here, right, what this would be equal to would be 35 over 37 times 12/13 minus negative 12 over 37 times 5/13. Right? So doing some arithmetic here, what you would get is 420 over 481 plus 60 over 481, which would be equal to 480 over 481. Right, so that would be the final answer. All right, so then the next objective is thinking about applying the sum of difference formulas for tangent, right? So I actually already gave you those for tangent in that chart, right? So we have them here, right? The tangent formulas. So you might be wondering, maybe where they come from, right? So I talked about how I won't derive the formulas for cosine and sine, right? You can review that on your own. But once you have those established for cosine and sine, it's pretty easy to find them for tangent then, right? Because we can think about, for example, the sum formula, tangent of u plus v would be equal to, sine of u plus v all over cosine of u plus v. Right, so we're applying one of the quotient identities we looked at in the last chapter and in 6.1. So then now what we could do is just plug in those formulas, those sum formulas for cosine and sine into here. So we get, sine u cosine v plus cosine u sine v all over cosine u cosine v minus sine u sine v. Right? And then it turns out to try to clean some of this up, what we can do is multiply this whole thing times 1 over cosine u cosine v all over 1 over cosine u cosine v, right? And what that will give us is the following, right? What we would have is, so if we distribute that through, right, we would have sine u times cosine v all over cosine u cosine v plus cosine u sine v all over cosine u cosine v, this would be all over cosine u cosine v over cosine u cosine v minus sine u sine v all over cosine u cosine v. Right, so that we can simplify some of this, right? So so the cosine v parts, these would cancel, right? And then in the second expression, these cosine u's would cancel each other out, right? So then what I'm left with in the top is sine of u over cosine of u plus sine v over cosine of v all over. And then notice in this fraction here, the top and bottom are the same, right? So that's just 1. So I'd have 1 minus. And then I could rewrite this guy as sine u over cosine u times sine v over cosine v, right? So that'll just make it a little easier to see something, right? So now what I can do is rewrite everything in terms of tangent, right? So sine u over cosine u is just tangent of u, and then sine v over cosine v is tangent of v. Then we'd have 1 minus, and then same thing, this would be tangent of u times tangent of v, right, which is the sum formula for tangent, right? So that's where that comes from, right? Just doing some algebraic stuff, right? So you could prove this identity in this fashion, right? So you could do the very same thing for u minus v, right? So plug in those formulas and try to simplify it and see if you can verify the other identity, right? All right, so now let's practice using this a little bit. So example 5, we want to be able to find the exact value of tangent of 165, right? So 165 degrees is equal to 120 degrees plus 45 degrees, right? Again, the reason why those two things are special is because 120 and 45 degrees are both on the unit circle, right? So we can rewrite tangent of 165 degrees as tangent of 120 degrees plus 45 degrees, right? So this is like my u, and this is like my v. So we want to use that sum formula. So what we would end up getting with this is tangent of 120 degrees, tangent of u, plus tangent of v, tangent of 45 degrees, all over 1 minus tangent of 120 degrees times tangent of 45 degrees. Right? So then if you need to, draw a unit circle. So here's 120 degrees, which leaves this with, 60 degrees. This is 1. This would be negative 1/2. This is radical 3 over 2. And then you could draw one for 45 degrees. So we get 1, radical 2 over 2, radical 2 over 2. Right, so then just filling in these appropriate values for tangent of 120 and 45. So what we end up getting, is tangent of 120 degrees is equal to, so it'd be, y over x, right? So we'd have radical 3 over 2 divided by negative 1/2. So I can multiply top and bottom by, negative 2. Right? Or in other words, if we just multiply or divide fractions, right, this would be equal to radical 3 over 2 times negative 2 over 1. So these 2's cancel, and what we end up with is just negative radical 3, right? So tangent of 120 degrees is just equal to negative radical 3. So then, tangent of 45 degrees would be equal to radical 2 over 2 over radical 2 over 2, which is just 1, right? So plugging those values in, what we end up getting is, so tangent of 120 is negative radical 3 plus 1 minus, and then we'd have negative radical 3 times 1, right? So this is equal to negative radical 3 plus 1 all over, 1 minus 3 would be 1 plus 1 plus radical 3. Right? So then what we want to do is rationalize the denominator, right? So think of this as a plus b. We want to multiply it by the conjugate, which is a minus b. Right? So in other words, we would take this and multiply by 1 minus radical 3. And we have to multiply the top by that as well. So what this gives me, so I have to FOIL the top, right? I would have, because what I have essentially is 1 minus radical 3 times 1 minus radical 3 in the top, right? Because this I can just rewrite as 1 minus radical 3, just changing the order of the add-ins. And then in the bottom we have 1 plus radical 3 times 1 minus radical 3. Right, so we need to do some FOILing here. Right, so multiplying, these two guys together, we get 1, and then 1 times negative radical 3 would be minus radical 3, and then negative radical 3 times 1 would be minus radical 3, and then negative radical 3 times negative radical 3 would be minus 3. And then now multiplying the bottom through, 1 times 1 is 1, 1 times negative radical 3 is minus radical 3, and then we need to take radical 3 times 1, so plus radical 3, and then lastly radical 3 times negative radical 3 would be minus 3. So simplifying this, what we end up with is negative 2 minus 2 radical 3 in the top all over, so these cancel, so 1 minus 3 is negative 2. Right. Hang on a minute. So this should be plus 3 in the top. So this actually is 4. Right, sorry about that. So if we take negative radical 3 times negative radical 3, that's just positive 3. Right, that's where I just made an error there with the sign when I wrote that out. So we end up with 4 minus 2 radical 3 all over negative 2. So in the top, I can pull out a factor of 2. And let me actually do negative 2. So if I pull out a factor of negative 2, what I end up with is minus 2 plus radical 3 all over negative 2. And then these two factors, I can divide top and bottom by negative 2. So what I'm left with is negative 2 plus radical 3. Right, so that is a simplified answer, right? Right, and just remember here, this part, we call this a conjugate, right? That's the a plus b, a minus b stuff, which you should be familiar with from high school and or college algebra, right? All right, so the next objective is using the sum and distance formulas to verify identities. So we have some new identities here, cofunction and periodic identities. So you can see those listed there. And notice it says, all statements can be made using 90 degrees for pi over 2, 180 for pi, and 360 for 2 pi, right? So you can, transfer those to degrees or radians, however you would like. So example 6, we want to verify the identity cosine of 3 pi over 2 minus theta is equal to negative sine theta. So using the difference formula for cosine, so we start with the left-hand side. The left-hand side is equal to cosine of 3 pi over 2 minus theta equals. So this would be equal to cosine of u, which would be 3 pi over 2 times cosine of v, which is theta, plus sine of u, which is 3 pi over 2 times sine of v, which is theta. Right, so I'm able to fill that in using that formula that we've been talking about. And then now I can evaluate, like what's cosine of 3 pi over 2, right? So if we think about, on the unit circle, 3 pi over 2 is here, right? This is 3 pi over 2. That ordered pair is the point 0, comma, negative 1. So cosine of 3 pi over 2 is equal to 0, and sine of 3 pi over 2 is equal to negative 1. Right, so filling that in. So what we would get is 0 times cosine of theta plus negative 1 times sine of theta. Right? So of course 0 times cosine of theta is just 0. This part is just 0. So this would just be equal to negative sine theta, which is what we were trying to prove, right? So this is equal to the right-hand side. So so that checks out. Right. So I have another one here to verify. So this is using the sum formula for sine, and also the difference formula. Right. So if we start with the left-hand side, that's sine of x plus y minus sine of x minus y. This is equal to, so if I begin to fill this in, sine of x plus y is equal to sine x cosine y plus cosine x sine y. Right, so just using some formula for sine that we have, right? So it might be helpful if you have that printed out by you. And then we have minus, and this is where you want to be careful respecting the whole thing, right? So what's going to go inside of here is sine of x minus y, right? So we're just using x and y's instead of v's, right? So this would be sine x cosine y minus cosine x sine y. Right, so now we just need to do some algebra here. So this would be, sine x cosine y plus cosine x sine y. So I'm going to distribute the negative 1 through. So this would be minus sine x cosine y plus cosine x sine y. Right? So then now we can combine like terms, right? So notice that this one and this one are going to cancel each other out, right? So what we end up with is cosine x sine y plus cosine x sine y. Right? So there's two of them here, so this would just be the same thing as 2 times cosine x sine y, which is what we were trying to show. Right? So we're able to show that. All right, so objective 4 is we want to be able to write a sum of a sine x and b cosine x as a single term, right? So let me show the motivation of where this is going to come from, right? The theory. So if we, let's say we just start with a right triangle, and I'm going to label this angle alpha. This is side length A, side length B, and this is K, right? So the idea here is we're going to let cosine of alpha be equal to a over k then, right, from this picture, and sine of alpha then would be b over k, for k is going to be a positive real number, right? So that's how we can label that, right? If you don't, again, this is just some shorthand for mathematics. If you don't like saying this, we could just say for some positive real number k. Right, you could say that out in words instead of symbols. Right. So for this for this exercise, we're going to consider the case when alpha is in between 0 to pi over 2. Right? All right. So now what we can write is sine of x plus alpha is equal to, so using the, sum formula, this would be sine x cosine alpha plus cosine x sine alpha. And so we know what cosine alpha and sine alpha are. We define those above, right, in terms of a, b, and k. So this would be equal to sine x times a over k plus cosine x times b over k. Right? So far, what I have is that sine of x plus alpha is equal to sine of x times a over k plus cosine of x times b over k. Right? So now what I'm going to do is I'm going to multiply both sides by k. Right? So what that gives me is k sine of x plus alpha equals a times sine x plus b cosine x, right? Because those k's underneath will cancel out, right? So you can see here that this right-hand side is what we are trying to describe, right? The objective is write a sum of a sine x and b cosine x, right? So that's the sum of a sine x plus b cosine x as a single term, which is this left-hand side, right? So this is kind of like our formula that we were trying to work with. And now, you might be curious, how do we define k? How do we find k? Well, so you could look at this a couple of different ways. The easiest way is just using Pythagorean Theorem from this diagram, right? So what that tells us is that a squared plus b squared equals k squared, right? So then if I take the square root of both sides, right, that leaves me with k equals plus minus square root of a squared plus b squared, right? But remember, we said that k was within the positive real numbers, right? So in other words, k is bigger than 0. So that's just going to cancel, that's going to get rid of that negative, right, in front. So k is going to be equal to the square root of a squared plus b squared. Right? So we have this information here. So this is known as what's called the reduction formula, right? Because we're going from a sum of two things down to one term, right? So a sum of two terms down to one term, so it reduces. It's a reduction formula. And I just have that written here, right? So what we had went through was kind of deriving that formula, right? So let's practice it with an example, example 8. So I want to be able to write -4 sine x plus 3 cosine x in the form k sine of x plus alpha, right? So the easiest thing to do, think about this, is just try to identify each part, right? So this tells me, A is -4. This part here, just label that. That's my B value, which is 3. Right, so I'm just using this and labeling each part. And notice here on this side, I need to find K. So K is equal to the square root of -4 a squared plus b squared, which is 3 squared. So that's going to be equal to the square root of 16 plus 9, which is the square root of 25, which is 5. Right? So K equals 5. Right? So then the other piece I'm missing is alpha. Right? We need to figure out what alpha is. So A is my my x value, right? If you will. From the picture, right? So like if I go back to this, A, like if this was like my XY plane, right? A goes with the x value, right? Deals with cosine. So so A is going to be negative, right? My x value is going to be negative, so I'm going to be, somewhere over here is -4, and then my y value is 3, positive 3, right? So if here's 3, then there's kind of my point, right, that I'm going to land at for my right triangle. So, we can label this. This is -4. This is 3. And my k value, which is r, which is 5. Right, so we want to figure out what this angle is, which is alpha. Right? So if you want this in, depends on if you want it in degrees or radians. It turns out, so what you'd want to do is we could do like inverse cosine of -4/5 is going to equal alpha, which is approximately equal to 2.4981 radians. Or you could do inverse cosine of -4/5, which is equal to alpha, which is approximately equal to 143.130 degrees, right? So it just depends on if you want it in degrees or radians. So now to fill in our statement here. So -4 sine x plus 3 cosine x is equal to, so just reading it from our formula, would be our k value, which is 5, times sine of x plus alpha, which would be, if you want it in radians, 2.4981. Or we could say it's equal to 5 sine of x plus 143.130 degrees. Right? So that's what we were after. And it didn't specify if we wanted radians or degrees. All right, so that's all I have for sum and difference formulas. Right? So make sure you let me know if you have questions. Thanks.